Guys, we start now. So, yeah. So there's a question about, just now we just have a chat, right? The question about system thinking, design thinking, how we integrate together. Wow, actually, I also developing a module for NTU. It called future thinking. So we have so basically you have something called hindsight, insight, and foresight. See the past, see the present, see the future. Hindsight, insight, and foresight. So you have different thinking process. Now, design thinking, the focus is empathy, right? When I do design thinking, for example, the development of the dialysis machine, 50% of my time is actually on understanding customer needs, all right? Empathy. And empathy, I believe that design thinking, you all learn a lot, right? So empathy has three phases, which is observation. So I think a lot of people skip observation. They go into engagement, which is the interview, the focus group, whatever, right? And I always insist on, so there are 3 steps in empathy, right? Observation, engagement, and immersion. Immersion is simple to understand. But from the anthropology point of view, it's good. From the business point of view, we don't have time to do all these 3 things, right? So but one of the still important thing is do observation, right? When you do interviewing, you came out with the customer journey mapping, correct? But customer journey map should derive firstly from observation, not from the interview. Why this way? Because interviewing will be more subject to social conditioning. This is, I think, what a boss would like to hear. This is what I think the organization would believe, right? So the interviewee are being conditioned. They condition themselves, not you condition them. They condition themselves. So when you do observation as a first phase to do your customer journey map, you actually are collecting objective data, right? So the purpose of journey map is to collect data, evidence, right? So when you start to end, you do it objectively. So for example, what I like to say is that you are like a fly on the wall looking at people doing his process, right? Doing his, let's say, processing of invoice for payment. Then you look at the different steps, okay? From that different steps, then you build a journey map. And once you build the journey map, that's the data, right? I got evidence. I can take picture or whatever. I got evidence. Then you go into your engagement, which is your interview. Your interview has 2 steps. And a lot of people just do interview in 1 step. Actually, the first step of interview is to do a big sweep of all the problems and the importance or the priorities. So basically you say, from the journey map, I can see the pain points, okay? So on the pain points, what I want to do is sweep through the whole thing, figure out the pain points, and then see how to prioritize, okay? Where are the important, is it the pain point 10 point, let's say level 1 to 10 or whatever. So if I can identify all the pain points, then the next thing I need, so I have an inventory of pain points, right? The next thing I want to know is which pain points I want to solve, okay? And then I go deep to find the cause of the pain point. Now you have 100 pain points. If your journey has 100 pain points, you're not going to solve every one of them. You're going to solve the one that has the most value add, correct? And then you need to find the cause of the other thing. So it's 2-step process. Then when people do design thinking, when they do the journey map, they forgotten to focus on the user. They focus on the product or services. So when I look at a processing point, I look at, for example, how you receive the document, how you sign the document, and blah 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 blah, right? But that's not the main thing. The main thing is the empathy. You empathize the user. You don't empathize the process. You track the user. So the start point and end point is the most difficult thing to recognize. And a lot of people probably look at it is, okay, I want to study this process. Okay, when the process starts, I study. The process ends, I study. Correct? But we are focusing on the user, right? And the user may have problems when the process is not in the perspective, in the picture. I think the simplest way is to give an example. So for example, let's say somebody eat lollipop. Okay, you eat lollipop before, right? At least young. So you eat lollipop. At the end, right, we focus on the lollipop. Oh, you need to throw away whatever. So when the lollipop finish and we have a stick we throw away, right, we consider process end. That is, you focus on the product and the process. But has the customer journey end? So where does the customer journey end? Think about it. Where does the customer journey end? Normally, after people finish the lollipop, right, it's too sweet in the mouth, and they will start drinking water, right? So when they start drinking water, the artifacts, the product disappear already. But the customer experience is still there. He needs to drink water in order to finish the journey. That's where the journey ends. And we never document that part. But if we focus on the user, I follow you, whether you go toilet or whatever, I just keep following the user, I will track. Eventually he will drink water, correct? But if I say, oh, finish, throw away the stick, done, you will never capture that part of the customer experience. So be careful on the start and the end of the journey. In between is easy. In between you can see. So you focus on the user, don't focus on the product or the process when you want to do design thinking, okay? So, therefore, design thinking is evidence-based but more qualitative. You just list out the factors, right? And when you do brainstorming and iteration, you change the factors along the way, but there's no simulation tool. Most design thinking don't have simulation tool. So the system thinking is trying to build a model and then simulate it and the time dynamics. So therefore, the system thinking allows you to experiment with many variables. While design thinking is like very focused on what we call the MVP, okay, which is current. Or the system thinking look at many stakeholders, which you can build into the systems. Okay. Any questions on this? Yeah.
Because we were talking about MVP, minimum viable product.
Yeah.
How does agility or agile thinking come into this?
I don't really do in agile, but MVP. Okay, my definition of agile is that you develop tests, right? You use what kind of techniques? Build, measure, learn?
Well, we could, okay, let's say automated testing, or we could use things like, let's say it's a development type, we could use things like JUnit, MUnit, the stuff.
Okay.
But those are tools to automate tests when we make some change. So it's about change, version control and all those things. So that's from application point of view.
Okay, so for design thinking, MVP, right? MVP has a whole process of iteration, right? We use build, measure, learn loop. So every build, measure, learn is you test the feature, right? The feature is a hypothesis, right? So you have a hypothesis, you design experiment, then you go through the build, measure, learn, and then after that you make the decision, you exit. So it's testing, learning, all right? Build, measure, learn, test, build, measure, learn, and then you have a decision making. When the decision making, you either pivot or don't pivot. That's the whole MVP process. Okay. You can when you do this testing, it's up to you to build what kind of features. You can build agility inside. I don't see that's problem over there because that thing is just a whole process. It's a flow. All right. I think the techniques most of the techniques, there's no need there's no need to be very fixated into this is the thing. It can actually integrate. That's what I feel. Okay. Any other questions? All right. Now, so we go into the toolkits. So we have a simple stock flow diagram. Just now you have the causality, right? So now we build in the boundary. Okay. So the boundary, we need to now know the boundary in order to build the system diagram, right? Boundary, there must be source or there's sink, source or destination. Then there's a flow. Can be flow of information, can be flow of goods or whatever. And there's valve. Valve is the one that controls the flow. Okay. And then there are stocks. Okay, so could be goods. Goods are stock, simple stuff like that. So you have a source, and then you have a valve for flow regulation, and it flow into a stock outflow. So inflow, outflow. So it's very simple, right? There's arrow, there's a regulator, there's a source, there's a destination. This is a linear flow. This is the only formula I'm going to show you. Don't bother lah. Yeah. What it means if you look at the flow, if you look at flow, right? When you have flow, you have a bigger flow, bigger inflow and a smaller outflow. So it's a black box, right? You put more things inside and you take less thing inside, then of course there will be more things inside the box. Correct? That's all. So don't bother too much about the formula. So what is a stock? Stocks are accumulations, right? Measured in units. You can be in dollars, you can be head count, depends on what are you measuring. Flows are the change in the level of stocks, okay? And it has time. So you always go by per unit time, per month, per second, or whatever, okay? So if you look at a system diagram and you want to say, to check whether it's the flow of stock, okay, that variable, very simple. You just say freeze, nothing move, right? When you say freeze, nothing move what? The stocks will stay. There's no flow. So now you know if I do a freeze and these things goes to zero, means what? There's no, it's a flow. But if these things quantitatively stay there, then it's a stock. Simple, right? Okay? Clear? Am I making things very complicated? No. So examples is very simple. So variables, therefore, because when we do system diagram, we have variables, right? And can exist in two forms, stocks or flow. And this is what it means. The simplest way is to a bathtub, where your source is the water coming in, and you have a regulator, which is your tap. You turn on your tap, you can increase the flow, lower the flow, right? And you go into the bathtub, and then your outflow, which is your what? Your plug, whatever, and then it allows things to go in, right? And therefore, very simple. Anytime you say freeze, that means you put in your plug, you close your things, there's no flow already. Then the stock, the amount of water is there, is your stock. Okay? Simple illustration. Okay? Now, let's have a little bit complicated diagram, right? So what is Singapore water policy? Okay? Well, we ensure that the potable water, good for drinking, something like that, but we have 4 national taps. Okay? So to ensure our supply remain robust and in all times. All right, so I think, and these national taps are here, right? The first one is always local catchment, which is our reservoir. The second one is import from Johor, imported water. The third one is new water. And then after that is desalination. All right? So now there are flow and there are stock. Flow from Johor. All right? Reservoir, where's the flow? Rain. Okay. Yeah, so now your job is to put flow and stock together. Where's the source? The source is here. The source is Malaysia. Where's the sink? Where's the sink? Household. You got industry there. Do we share the same? Is it Jurong Island the same or whatever? New water, does it go, right? So now is to apply the stock and flow concept. Go and draw a diagram. Okay? Draw a very simple stock and this is a simple stock and flow diagram of our water policy. Now we're modeling the Singapore water system. Okay, reservoirs are your stock, huh? Reservoirs are your stock, right? But the reservoir will have to flow into a processing plant first. Imported water and rainwater is quite easy. It is the new water that's complicated. New water, remember, new water doesn't straight away go into our household, right? Because new water used for factory, some part used for factory, 10% of the new water goes into the reservoir. Oh. New water is never given direct to the household. Okay, how about the runoff? How about the drain water runoff? Longkang. Well done. Okay. Now things get, you start seeing complication, right? You start seeing, I have this source of water, this source of water, 4 taps, and then you start linking them together. You start seeing your system diagram emerging. Okay? Yeah. So that helps you how to think in system. Okay? All right. Let's take a look at the Singapore water system. Okay, we have 4 sources. Okay? How many sinks we have? So look at the boundary first. Always start with the boundary. We have 4 sources. How many sinks we have? How many destinations we have? Household, which is 1, and industry, right? So we have 2 sources, okay? Yeah. We used to only have 1 source, one destination, 1 sink, which is household, because all the water is the same. But because industry, we don't need to treat them so well, right? So therefore, that's the system diagram. Okay? So if you look at, maybe I will just say, look from here, right? Rain, right? Rain, of course, go into stormwater management, right? Of course, it can fall directly to the reservoir, but it go to the drains, whatever. All these stormwater go into collection into the reservoirs. All right? Anything that falls on any single drop of water in Singapore doesn't go into the sea. It goes into the reservoir. So in the reservoir, you do a treatment, then you transmit it to either the industry or the household, right? Then the desalination plants doesn't go into the reservoir. Straight away go out because it's treated. No point treat again. Okay? It's including cost, right? And then once it goes out, collection of used water, DTSS, you know our DTSS, deep tunnel system, all the sewage things, go back treatment, then go into a new water. New water go for basically what? Industrial use. Okay? And then 10% go into, some of them go into a sea, but that was the sludge part. The indirect one goes into the reservoir. That's the 10%. Okay? So new water never go directly to household one. Okay? That's our policy, right? Okay, so now you can start looking at stock and flow, source and sink, boundary. All right, that's the purpose of this exercise. Identify source and sink, where are the stock, where's the boundary. Okay, and then we can go more complicated picture. Huh?
So it's selling to Malaysia,
No, not inside. Selling to Malaysia is the household water. Yeah, we don't sell reservoir water back to Malaysia. I treat it as household water. Yeah, because it's just another pipe out. Yeah. Okay, now, this is stock flow, okay? Raw material, finished good, and shipments. Can you draw? Now, you can make it very easy. You can also make it very complicated. But it's yeah. Raw material comes in, finished goods goes out, shipment. Simple. You can draw it just one straight line. But you can also make it very complicated. Why? Because raw materials, finished good, not what's the yield rate? Not 100% will be finished good. Some will get rejected. Rejected, what do you do with it? You discard. You rework, you recycle, whatever. So it can be, now we start seeing a big complication here, right? Okay, start with the simple one. Start with the one single line, okay? So you have raw materials, which is your source, right? Go into your production finished good, shipments. Finished goods are stocks, okay? That's a variable is stocks, all right? Raw materials or the materials inventory are stocks. So your flow is your receiving. Then their production, their shipment to somebody else. So you order for somebody's factory, you receive it into your materials inventory or your warehouse, stock. Then you go production, which production is a flow process, okay? Production is a flow process, goes to the finished good, which is stock. Then shipping is flow process, right? This is how we model, right? Simple, right? Okay, now we make it a little bit complicated. Finished goods, rejects. How do you handle? Finished goods, rejects. How will you handle? Okay, maybe you can rework, yeah. So finished goods, rejected, rework, right? Repair, scrap, go back to materials inventory. Now you start seeing loop. Okay, so for the complicated mind, this is getting complex, but step by step. Think slowly, step by step. All right, anything else? Okay, try this. This one probably nothing to do with production, right? Recruitment, inexperienced staff, experienced staff. So you do recruitment, you get experienced people, no need training. Non-experienced people need training. Okay, this is the simplest, because you always start with the stock flow process, so it's very simple, right? Now, what are the variations? Okay, you can start putting in the variations. All right, so you have recruitment, right? New hires, you finish entry, right? Finish the new hire, finish the process, then they are inexperienced staff, then with training and experienced staff. But obviously, your new hires can have experienced staff. Right? Yeah, so your experienced hire can go direct to experienced staff from the new hires. Okay? Which one? Completion of the hiring process. Onboarding audit. Okay. What else? Yeah, it's up to you to design. As long as it makes sense to you. You've forgotten, some people cannot. Wash out. After training also cannot get out. So we call it 3 months probation. Okay? All right. Simple. Now you see your mind get a little bit complicated from a simple process. Okay? Yeah. Okay, causation and correlationship, we done already. Okay, now before I go to causal loop diagram, right? Simple exercise, right? For your work, you have something that you want to design. Can you all think about it? Boundary, the key variables, and how it related. Can you draw a slightly more complicated rather than just one single line diagram? Okay. Okay. Choose among yourself. It doesn't apply to your work now. All right. Okay. So you have your own process. Every group. Okay. Guys, stick to it. Stick to it, right? Something that related to your work, stick to it. Very simple process. You can make it complicated a little bit more, but a simple stock flow process, because later on, I show you the computer simulation, and then I expect you to key in into that simulation. So hopefully you have a computer, at least one table has a computer to simulate your process. Right? It's not just design, you need to simulate because you will never know what's the outcome until you simulate, okay? Right. So yeah, like the software I'll teach you how to download later, so step by step. Because I tell you to download, you probably don't know where to start. So slowly, right, you will eventually see your output, whatever you draw in the computer simulation, okay? Now let's go to causal loop diagram, right? So in system thinking, causal loop represents most of the time, everything is not just a simple flow. You start, when you are drawing your diagram, right, weather water policy, you start seeing, once you settle the initial flows, then things have variation, and you start feedback, right? Finished good, got rework, you start seeing a loop already, okay? So therefore, we need to understand all this looping mechanism. So the two simple loops are reinforcing loops and balancing loop. This is the basis of everything. You don't understand this, you don't understand design thinking. Simple as that. All right? So the basic loops is the building blocks of our complex social and economic system. All right? So whatever things is coming down to this loop. It's the combination of this loop, how you arrange, which makes things very complicated. And that's how we try to model the real world. Okay? All right, so there are basically a lot of ways. You have the slides, I will give it to you. So the first thing is reinforcing loop, all right? And we indicate it with the R, all right? So we know is reinforcing. So it produces results in the same direction in the growth or decline. So it's like a positive lah. You see, we draw one to here, positive is output, right? But if we come back, then it's like forever looping, right? Okay, so that's a reinforcing loop, all right? And how do you look at this? Is like that, okay? You and so same direction, okay? We have same direction and opposite direction, right? When you look at the arrow, so S means same direction, except that instead of drawing a straight arrow, now we curve the arrow back and a semicircle, right? So employee performance supervisor supportive behavior will support employee performance. Employee performance will reinforce the supervisor, right? So it's always that you work very hard, you get more job. See, right? Better performance always get more job. The boss will keep on giving, right? Then the lousier performer, less and less. Right? So it's either you go up or you go this way. So it's the same loop. Right? It's either positive reinforcement or negative reinforcement. Okay? So that's how we can track performance level. Of course, this is like the simplest example that we always use is that you put money in the bank and it's like what they call compounding. Right? You just keep on compounding. So that's the simplest loop. So when you look at the thing, anything positive is a compounding loop. Okay, let's try. This should be simple. Employee morale should be positive. So employee morale high, work efficiency will high. Employee morale low, work efficiency will low, right? Then they just go back. Okay. So this is simple, right? Okay. How about this? Try this. So where should you start? Tax rate. Is that a tax rate? Tax rates will influence the profit. Mm-hmm. So as a positive or negative sign when you draw the arrow. Country tax revenue increase. Do you increase or reduce the tax rate? Yeah, you should reduce the tax rate, right? If you collect a lot of money, why should you keep on collecting? Yeah. Okay, so if a tax rate reduce, company so tax rate reduced, right? So it's a negative, right? The company profit will increase. Company profit will increase, more private companies. More private companies, more country revenue, tax revenue, more country tax revenue, lower tax rate. Doesn't apply to Singapore government. So you see, our first thinking is that there is this plus, right? One plus, the other plus, correct? This is the thing, one plus and plus. So plus, overall is plus. Then now you have plus, minus, minus. Is it a reinforcing loop? Plus, minus, minus. No, it's reinforcing. Because ultimately, reduced tax rate increase in country tax collection, so it's reinforcing. So doesn't mean reinforcing loop, everything must be plus. So what it means is reinforcing loop, plus, minus, minus. As long as you have the minus is even number, is the reinforcing loop. Even number. So if okay lah, it's a long way of analogy. Minus equal plus. Okay, yeah, but it's a long analogy, but it's easy to think that way lah. We always say minus plus, right? Mathematics, right? But it's wrong analogy. But basically, if there are zero minus or even number of minus, is a reinforcing loop. Okay, so it's very important because when you do designing and you want it to be a reinforcing loop, you must go and compute the number of minus. Because plus no need to compute, right? You must go and compute the number of minus. Yeah.
Ours is
1 minus?
Is it 1 minus? Then
2 minus.
Where is the 2 minus?
Okay.
This is like negative plus.
Reduce tax rate, when your tax rate reduce, what happen? Company profit go up. It's also a minus.
Oh.
Company profit and tax rate are in reverse direction.
This minus.
Yeah.
Minus.
So bottom is minus, plus. Okay? Then, so this is reinforcing loop. The balancing loop is trying to, okay, so the balancing loop is, reinforcing loop is trying to increase or reduce, okay? But the balancing loop is trying to balance to a stable condition. Try to bring it to a stable state, all right? Reinforcing loop is like go up or go down, growth or decline stage. Balancing loop is, I try to make it stable. So sometimes when you make decision, you want a system to be stable, you must use balancing loop, okay? So therefore, it's try to move the current states to a desired state. What do you define as a purpose of your system? You want it to be like productivity go up to that. Do you want productivity to go? I think it's difficult to keep on doing this way, right? You want to say, I want productivity to reach 90%. Then you design such that you have growth using the what I call the reinforcing loop, and then you must incorporate that into a balancing loop so that it stabilizes. Else, it keep go up, it will be unstable, okay? And therefore, the balancing loop is to bring you to a desired state or goal, right? All right, so this is the balancing loop, right? You can see it. So this balancing loop has 1 plus, 1 minus, right? So it's 1 minus. As long as you have odd number of minus, is a balancing loop. If you have even number, it's a reinforcing loop. Okay? Simple principle, like rule of thumb. Once you understand, it's easy. Then when you design, you see your decision making is, do I want growth? Do I want balance? Or I want, like what I think he said, right? Growth, and then I want to balance. Maybe I want it to come down. Depend on, right? So if you want to come it down, you have to do this loop up, balance, down, which is reinforcing, balancing, and reinforcing. So we'll talk about how to actually design all these things, right? So here you have hunger. Hunger, you increase food consumption, correct? Food consumption means what? More people get hungry, right? Yeah. So that's the balancing loop. Okay. Exercise. So inventory require is sales, right? Some people buy, so that's the inventory require, right? Order comes in, that's the inventory require. And then you have shortage, what? So which loop? You cannot overproduce, right? Because inventory, you try to meet exactly the inventory require. But there's always lapse on. So you must balance. Existing inventory will what? Okay, production will increase existing inventory. Correct? Yeah. So existing inventory, when you go to inventory storage, will what? When you have increasing inventory will reduce the storage, so it's a minus. And if inventory shortage, what happened? You increase production. So more shortage, more production. More shortage, more production is a plus or minus? It's a plus, not minus. A lot of people think minus. So you have a plus, plus, minus, correct? So a plus, plus, minus is one negative. That is a balancing loop, right? Okay. Okay. So this one is a MCQ, very easy. What is this loop? Reinforcing, right? So reinforcing, you must put an R there. Okay. What is this loop? Balancing loop. What is this loop? Reinforcing. All right. 2 minus. All right. Yeah. That's the final rule of thumb conclusion, right? To determine, you look at the negative sign. If they are even, there's reinforcing. Odd, minus is balancing. That's all. Simple. Okay, don't need a copy. I'll give you the. Actually, I send the slides out already. Okay, then. So give you more couple examples, right? I think this is the example that we showed just now, right? But I add in the stock flow. Okay. So desire, you start with desire inventory, then there's inventory gap or inventory shortfall. So shortfall, production, but now I add shipments comes in. All right? So start with a simple loop first. Don't try to complicate things. Start with a simple loop and then slowly add in other stuff. Okay, then obviously there are times where things are delayed. So there are time delay. So maybe, you see, we are saying that inventory shortfall, you go production. But when you go production, the time is needed for production. All right? And therefore there are delay into the production, to the finished good process. And therefore, this whole thing is not going to just jump up straight away, right? It will be slowly moving up due to the shortfall. Okay? In engineering, it's called hysteresis. Not hysterical, right? Hysteresis. Yeah, you don't bother too much about those things. Okay, can you draw the time delay here? Think of where the population, right? Birth control to add to the population, right? Death take away from the population. Okay, so is there any time delay? So you got the loop, right? Loop. Where's the loop? Where's the loop? The population is going to give what? Where's the loop? Where do you think is the loop? So it's not a simple line, right? If I want to do a loop, right? Birth contribute to population positive. Death contribute to deduct from population is the negative, right? So where's the loop? The population will have birth, right? But then there's a delay. Why? Because you cannot produce another baby. It takes at least 18 years or average 20 years. Singapore 30 years, right? Developed countries is higher, right? And then you go to India very fast. But even if you want to model the racial population, right? In Singapore, also very different. But we do average. Our total factor productivity is how many? 1.1. Yeah. I think the Indian or Malay is 1. Even Malay is 1.6. Right? I think Chinese 0.9. Cannot even replace yourself. But logically, the total, the population, total productivity, not productivity factor, total fertility rate, right, should be 2.1. Then you can replace the population. All right? Our average is now 1.6. Right? So by 50 years later, we disappear. That's why you need immigration. Okay? See? Now you see the loop, right? So population will cause death. Death, no lah, it will take a long time before. So you have to figure out what's that, your average lifespan. And then you put a delay there. and then contribute. So now, from a single line, you now produce a loop, but there are delays. Okay, I think in simulation we try not to use delay. It just complicate a lot of matters. But when you are more familiar, we will just put in more delays. Okay. All right. Okay, under good. So now you learn all the basics already, and let's go into actually the purpose and the process and the structure, right? So we need to do simulation. You just need to go and type to VenSim, right? And there's a commercial, what's that? There's a free downloads. Okay, there's a free download. Your computer cannot download. How we solve the problem? Cannot download, then how cannot use? So what I will do is that I will demonstrate so you can download, and later on I will demonstrate this exercise, which is very simple. It's almost a straight flow. And then when you design your own program, maybe later, or when you have sort out, or later you go back, you can design, okay? So this is very simple, okay? Customer acquisition and sales, we try to do a simulation over time, the dynamics time. So the customer is a monthly rate, then the customer will buy, in your case, computer, right? So buy hardware and then buy service or software. So you go by subscription, right? So customer will, so if we look at it now, this is how we will draw, right? Okay, first the customer will come in, that's the acquisition rate, all right? So customer, let's say we assume this variable comes in regularly, okay? That means your customer over time over here is, let's say 10, and it's a linear number, right? So there's no fluctuation. So every month there will be 10 customers, and then we know that the customers, right? Every month, if it comes in, right, the stocks, those who are your customers who are into your subscription, is therefore month 1, 10 guys comes in, month 2, 20 guys comes in, and then month 5, of course, 50 guys inside your system, right? Month 2 is 10 plus 10, right? So this, therefore, your output is a linear graph, right? You must, when you design your system diagram, right, you must know exactly what's your output, what you are designing it for, okay? What's your purpose? Because your purpose will tell you what's the output. So you say, okay, my output is roughly going to be like this, increasing customer base. And therefore, when we start, this is the source, acquisition rate, and then this is a customer, represented by these two charts. Okay? Now, then we have, what we have is this is hardware sales and software sales, or subscription sales. So these are variable. I need to know where are the details. So hardware sales come from new customer comes in, right? New customer comes in here is the acquisition rate, right? And you, based on that is, each hardware costs how much? So I say, therefore the hardware sales is this times this, right? This times this. Then the software sales is basically sales of existing customer and the customer stocks, the number of customer, right? So subscription sales, monthly sales times number of customer, right? So this. So what we do extra is try to compute the shares, so SHARES, hardware shares of sales. This is the percentage of this divided by the total sales, hardware plus software sales. It's very simple, okay? So we try to model this simulation and see what's the result. Okay, now I roughly must have the formula, else how I input, right? Correct? So very simple, right? If I say this is A, 10, this is a variable A, then C is $1,000 per customer. So CX, which is hardware sales, is A times C, okay? Then B is the number of customer. Then D is $100 subscription per month. So B times D is equal to Y. So hardware sales, percentage of total sales is X over X plus Y, right? So now I have defined all the variables. So I can then key into the system, right? Else the simulator will not generate for you. Okay, so you need to know the variables and how you, so this part is the design. because I still do not know overall the result, how it look. So I design it first, I put in the variables, I key into the system, then I can step year by year, and then see how it flows, okay? Now, obviously, some people will make this very complicated, like it can be flow this way or whatever, it depends. Some people can make it seasonal. December more sales, January less sales. You can actually input it, okay? All right, so now that I design and roughly know how the system look like, I can roughly guess my hardware sale over the percentage of sales will be exponential decrease. This is expected, my expected. So whether my simulation result shows, it depends, right? We'll see how it goes, all right? So firstly, we start the Vensim software. I'll show you later. But let me step through the software first. Okay, we save a new file. Okay, so you can call it exercise 1. And then I save a new file. Then I start a new model. Okay, you see here, there's a new model. I start a new model. I click on the new model. Then it will ask me what is the time period. So we need to do simulation over a period of time. So I put 0 to 100 and step 1. So it could be monthly. Okay? All right, so the unit for a time is month, okay, monthly. Okay, then I'm done. I save it. Okay, then save results on every here I put every times is 0.25 steps. Okay, done, right? So 1 to 120, sorry, 1 to 120 at 0.25, which is like quarterly. Okay, now I go to the S, which is the stock. So I put in the stock first, which is the customer, so the stock, okay? And put in the source. The source will be a flow into my stocks, right? It's the customer acquisition rate. So when I click this, I have this arrow. Okay, you have to get used to it, because you click, sometimes you click 2 times, it disappears. So you click and you drag. Okay, the important thing is you click and you drag. Okay, this software concept's a little bit old because it was developed quite a long time. All right, must get used to the old way of doing software. Okay, click and drag. And so I click, so I have a flow rate to the customer, which is a customer acquisition rate and customer. Okay, this is very simple already, right? Now, I need to put in the variables, which is what is this my variable, and still over here, yeah, I will need to click on here, and I get my key in my function, customer acquisition rate, and customers. Okay, this is a variable, right? The variable has a flow rate and has a stock. So I key in, right? So done. Then after that, I click on the customers. I need to specify the unit. Okay, it's the number of unit. I can specify people, number of people who are my customer. Initial value is 0, so no customer in my system. I start from 0. Okay, so done. And then the customer, then I click on the customer acquisition rate, and there's a formula here. My equations, since it's constant, I put 10. Okay, then this is number of people per month. The variable, right? Number of people per month coming in per month. Okay, all right. So now I'm done. Okay, I have the customer acquisition rate defined, and I have the customers defined. And okay, now I can run name. I can save it as a current first. Okay, or base as a starting point. Okay, now when we click on the tools, we can actually see that the plotting chart running for 120 months, this is the output, which is actually exactly the same as what we predicted, right? Which is a linear graph. So now, what does it tell you? It tells you actually at any point in time, I can click on all this and I can see a dashboard of what's happening in the system. Every variable, which is very good because, and I can simulate 120 months, I can simulate step by step. So I can see the changes, right? So when you, I mean, this is very simple, but if it's complicated, you will start seeing that at what month where systems are getting unstable or whatever, right? Where are the changes, okay? But the important thing is you can see the graph now, right? Because we want to have the visual picture. So it's a very simple two-step process. All right. So now I see the customer rate already. I can shift the graph to anywhere I want on the screen. Now we click on the customer rate again, and we want to figure out, okay, let me see. Yeah, so now I can save it as a base, and I can see the rate there. I can also click this graph, and I can see everything. Okay, that means I can see the two variables. I can see all, this is the dashboard. So I can see the linear and, the fixed one and the linear graph, which is what I predicted in the earlier days, right? So you must have a mindset of what you are input and what you want in the output, so that the simulation you get doesn't run too much far away from what you predicted, okay? All right, and you can see your customer base at every timestamp. All right, now we need to have, now we can add in extras on the variables. So when you click this arrow, right? So I say, okay, there's an arrow here that I click that I define our variable and hardware sales. So I key in hardware sales and software sales, and I link my flow rate to hardware sales, okay? Because the flow rate will determine my hardware sales, okay? And then my customer will link to my software sales. This is the monthly number. And of course, I can make it very nice it's a straight line, and then I can curve it. I just drag, okay? Now, I key in 3 more variables, okay? Here, I key in 3 more, and then I link them up, all right? Using the arrows, link them up. Okay, here, link here. So this is hardware sales. So hardware sales is from customer acquisition and hardware sales per customer. Software sales is from customer and software sales per customer, and then the hardware sales and software sales percentage are linked together. Okay, now I need to input the formula, right? So where are the formula? The formulas are here. These are fixed numbers. Sorry, these are formula, and these are fixed numbers, okay? So you have a function, and you click all the variables. It will all appear, highlighted, they are not defined yet. And you click on that hardware sales, then you can say, okay, this is dollar per month. Hardware sales is dollar per month, and you will start seeing this customer acquisition rate and hardware sales per customer comes in the picture. You don't need to key in. Reason is because you already link these variables. You already link both of them here. All right. So when you click on that variables, these two will come up. Now you have to define the formula. So it's customer acquisition times hardware sales. Use the multiplication here. So I give you the step, right? Step 1, click this, click step 2, click multiply, step 3, click number of sales customer, okay? And now you got this. Then you go to software sales, same thing will happen. Click the customer, multiply times software sales per customer. Every time you click, these things will appear. All right, so then the next one, hardware sales per customer, very simple, it's $1,000, right? It's dollar per person or per people actually. Then you got to click the software sales, dollar per person per month, and then hardware share of sales is then the formula of, right, x divided by x plus y, right? X divided by bracket, so x plus y, okay? Simple, okay? Yeah, and then we're done. Okay, so if we click the unit checks, because we want to make sure that the system, all the units that we multiply are correct. So when you do a unit check, then the different units are okay. If it's not okay, go back and relook at all your formula. All right, maybe your definition is person and people is different, right? It must be identical, okay? Yeah. So it's quite flexible. You can PER, SON, it's up to you, okay? All right, then what you do, you run the simulation. You click here, you key in the run name, and then you run the simulation. Now I can see all my graph. You see the three graphs that I well defined, right? The 10% per month, the linear, and the hardware sales percentage. I can see every single point, which means you have a dashboard. So that's the good thing, right? Because every time you step through, you see changes everywhere, and then you can spot where are the things that doesn't go according to your prediction. And then you can modify your variables. It means modify your conditions. Okay?